In Lesson 5, we're going to look at forming images in curved mirrors, but specifically images in a type of curved mirror called a concave mirror. Our goals for this lesson will be to use light ray diagrams to locate images in concave mirrors, then tell the difference between real and virtual images, and finally describe the properties of these images using the SALT acronym. To get started, think about where you have seen curved mirrors in your life. Take a moment to pause the video and write down anything that comes to mind in the box below. When you're ready, click play to resume. Okay, so in the last lesson we talked about plane mirrors. Remember, these are perfectly flat, smooth mirrors, and you tend to find these maybe in your bathroom, in your hallways, etc. But there are actually lots of examples of curved mirrors in everyday life. Answers will vary, but a few common examples include headlights, so the headlights on your car will use curved mirrors to bend the light in a certain way. Another example would be a shaving mirror. And for one more example, curved mirrors are used in telescopes. Okay, but these are just some of the examples. Of course, there's many, many more. So with that being said, this lesson will focus on curved mirrors, and generally speaking, there are two types of curved mirrors. The first are what are known as concave mirrors, concave mirrors look like this. If we have incoming light going from the left to the right, from the direction that the light is coming in, concave mirrors bend in or cave in. They look something like this. So the reflective part would be on the front and the opaque part would be on the back. The second type are what are known as convex mirrors. And once again, if we have light coming in from left to right, convex mirrors bend away from the light, like this. So the shiny or the reflective part would be on the left, and the opaque part would be on the right. So a useful way to think of the difference between the two is that concave mirrors cave in. And convex mirrors, they either bend out or cave out, either way. Here we'll say bend out. Now we're going to briefly look at how concave and convex mirrors are formed. They're actually cut from circular pieces of glass. Now we're going to look at some terminology when it comes to concave and convex mirrors. Looking at the picture below, imagine a circle that includes both a convex and a concave mirror in it. So the convex mirror is on the left, the concave mirror is on the right. For the convex mirror, the dark part of the line would represent the reflective side, so let's make a note of that. And the back part would be the opaque side. Remember, we usually use this hashed line to represent that. Okay, so notice that the reflective side would bend away from the light. For example, if we had light coming in from the left to the right like so, you'll see that the shiny part of the mirror, or the reflective side, bends away from the light, which is what convex mirrors do. And for concave mirrors, we'll take a look on the right side of the image. Once again, the dark part of the line would represent the reflective side. And on the other side, we have the opaque side, which is again represented by that hashed line. I'll just sketch that next. Okay, and if we had light coming in from the left to the right, you'll see that the light is approaching the side of the mirror that caves inward. Okay, so one piece of terminology, you'll see the point labeled C. This is the center of this imaginary circle, and we call this the center of curvature. When these mirrors are manufactured, they're actually cut from circular pieces of glass and formed into mirrors. And the center of curvature would be the center of that circular piece of glass. So with that being said, everyone, this gives you an idea of how convex and concave mirrors are made. For the remainder of the lesson, we're going to be focusing on concave mirrors, the mirrors that cave inward from the direction that the light is coming in from. Alright, so as I just mentioned, we'll be focusing on images in concave mirrors for the remainder of the lesson, and to help us with this, we're going to look at some important terminology. So for all of these diagrams, we're always going to assume that light goes from the left to the right. Kind of like when you're reading a book, you read left to right. So you can always imagine that light is coming in somewhere from the left and moving towards the right. And therefore, from the direction that the light is coming in from, notice that the mirror caves inward. Hence, it's a concave mirror. Alright, so let's label a few important points. This red dot, that would be the center of curvature, and we saw that on the previous page. Next up, you'll see we have this horizontal line that passes through the center of curvature. Just to make it clear what I'm talking about, I'll highlight the horizontal line. And this horizontal line, we call it the principal axis. Next up, you'll see a point labeled V. We call this point the vertex. And the vertex is defined to be the location where the principal axis crosses the mirror. Next up, you'll see a point labeled capital F. We refer to this as the focal point or the focus point. And we'll talk more about what the focus point does in a little bit. One thing I'd like to notice that we use capital letters to label the center of curvature, the focus point, and the vertex. So please make sure you're using capital letters to label it in all diagrams going forward. Okay, and I'll just color code it so you know what I'm talking about here. So let's talk about the focus point. We label this with capital F, and this is defined to be the point that is right in the middle between the vertex and the center of curvature. So in this lesson, we're dealing with concave mirrors. Mirrors reflect light, so we're going to look at how light rays are reflected in a concave mirror. To help us with this, there are 4 rules that we need to know, and I'm going to recommend that you take out 4 different colored pens or highlighters to help you with this, and I'll color code it as well. So let's get started. The first thing we'll do to help us out over here is we'll draw an object. Let's say our object is an arrow that's positioned on the principal axis. I'll draw it over here. Okay, so this is our object on the left. And the object can be whatever. I'm using an arrow, but it could be a person, it could be a pencil, anything really. The first rule is for a light ray that is coming in parallel to the principal axis. So let's begin by drawing that. When this light ray hits the concave mirror, it's going to reflect, but it's going to pass through the focal point. So here's the reflected ray. And that's going to be our rule number 1. All right, so please color code it to help you understand the different rules. Rule number 2 says, an incident ray of light that passes through the focal point will always reflect and come out parallel. It's sort of like the opposite of rule 1. I'll draw that next. So here's our incoming ray of light that passes through the focal point. When that ray of light hits the mirror, it comes out parallel. Rule number 3, an incident ray of light that hits the vertex will follow the law of reflection. And remember, that tells us that the angle of incidence is equal to the angle of reflection. So let's draw that. Here's our incoming ray of light. It hits the vertex, and it comes out at the exact same angle that it came in at. Okay, so to help you with this, I'll continue color coding. We have one more rule, and this is that an incident ray of light that passes through the center of curvature will be reflected back the same way. Let's draw that next. So here's our incident ray of light. It passes through the center of curvature. That's point C. All right, and then it just reflects back and goes the same way. And that would be our rule number 4. And the reason for this is the ray of light is actually hitting the mirror at a 90-degree angle, so it reflects back in the same direction. So you can add a 90-degree angle where ray number 4 hits the mirror like I'm doing right now. And there you go, everyone. Those are the 4 rays of light that are going to help us find an image. Now, you may be wondering where the image is. So I'd like you to look at the picture I drew and notice that those 4 rays of light tend to all intersect at one location. Do you see it? Okay, I'd like you to zoom in right about here. You really need to use a ruler when you're making these diagrams because it definitely makes it more accurate. But the image is going to form right about here. Okay, so the location where all of those rays intersect tell you the location of your image. And we'll later use the SALT acronym to quantify the image. But what I'd like you to see right now is that the arrow is upside down, so it's an inverted image. Hopefully that was clear. Let's move on to some more practice. So here are the 5 steps to finding images in concave mirrors. And really it's just a summary of what we did on the previous page. So you're going to draw those 4 rays of light. Let me just summarize them. The first one is a ray of light that is parallel to the principal axis and reflects through the focal point. The second one is an incident ray of light that passes through the focal point, but upon reflection comes out parallel to the principal axis. The third one is a ray of light that passes through the center of curvature and travels back along the same direction. The fourth one is a ray of light that passes through the vertex. It reflects at the same angle that it came in at, following the law of reflection. And rule number 5, which I showed on the previous page, the image will be at the location where the 4 rays of light meet, always. But you really need to make sure you're using a ruler, because if you're not, your diagram won't be very accurate. So I'll just make a note over here. You're going to have to use a ruler. All right, so we're going to practice now. But to do so, we're going to look at different cases. Case number 1 is one where the object is past the center of curvature. In other words, it's to the left of C. Okay, so here we go. I'm going to draw the 4 rays of light. By the way, the order you draw these in doesn't matter. So the first one I'm going to draw is a ray of light parallel to the principal axis. This one reflects and passes through the focal point. That's number 1. The second one is a ray of light that passes through the focal point. It reflects and comes out parallel to the principal axis. The third one is a ray of light that passes through the center of curvature. It looks like we're going to have to extend our mirror a little bit. No big deal, just do so, please. So let me redraw that ray of light. Okay, and the fourth ray of light is one that hits the vertex. So the vertex would be right here. And it's going to reflect at the same angle it came in at. So something like this. Okay, so I hope that wasn't too confusing. And you're going to notice that the 4 rays of light appear to intersect somewhere over here. I know it's not exact, And it's never going to be perfectly exact, but in all honesty, this is fine. So the image will be approximately at this location here. And now we're going to quantify the image. So first of all, let's look at the size. Now, to me it looks smaller, but perhaps you could verify this. Just use a ruler, measure the original height of the object, whatever that is, and compare it please to the height of the image. You'll probably find that the image is smaller. Notice that the arrow is inverted. As for the location, notice that it's between C and F. And this type of image will be a real image. So just to remind you, when we were talking about plane mirrors, they always formed virtual images. You can form a real image with a concave mirror. So just to make it clear, everyone, here's our image. And I'll just get rid of this height over here. And this would be your object. So remember, we're breaking this up into cases. And it turns out that these properties of the image will always be true for case 1. So images formed when the object is to the left of C in a concave mirror will always produce images that are smaller, inverted, between C and F, and real. So you can make a note that this is always the case for the image. Let's move on to case 2. What happens when the object is on point C? So we'll get practice drawing the 4 rays of light again. The first one I'm going to draw is a ray of light that comes in parallel to the optical axis. And remember, that one reflects and passes through the focal point. The second one I'm going to draw is a ray of light that passes through the focal point. That one reflects and comes out parallel to the principal axis. The third one I'm going to draw is the ray of light that passes through C. This one's actually kind of funny to draw. Notice that a ray of light that passes through C will just head straight down. And that ray of light will head downward, and you can imagine if this mirror is extended, it'll eventually reflect and come back up the way it came from. We'll get rid of this though just to make it a cleaner image. And finally, the fourth ray of light that I'll draw is the one that passes through the vertex, which I'll label above. So this one passes through the vertex and reflects at the same angle it came in at, so something like this. And it should be clear that the 4 rays of light intersect somewhere about here. All right, so I'll sketch the image below. Now, although it may not be perfectly clear from the diagram, here are the properties of an image for case 2. First off, the size of the image is the same. As for the attitude, it's inverted. As for the location, it's exactly at C. I know in my picture it maybe looks like it's a little to the right of C. It should be right at C. And this would also be a real image. Okay, so this will always be true for objects that are placed at point C. That was case number 2. Let's move on to case 3. What happens when your object is between C and F? So here we go. We'll draw the 4 rays of light. The first one I'm going to draw is the ray of light that the ray of light that is principal to the first one I'm going to draw is the ray of light that is parallel to the principal axis. Remember that one reflects and passes through the focal point. The second ray of light I'm going to draw is one that passes through the focal point. When that one hits the mirror, it comes out parallel to the optical axis. The third one I'm going to draw is the one that passes through C. When this one reflects, it just comes back in the same direction it came in at. And finally, the fourth one is the ray of light that passes through the vertex. That one reflects at the same angle it came in at. Okay, everyone, you'll have to forgive me. I'm doing this on a tablet, and although I can make straight lines, I don't have a ruler to make sure that everything is really parallel. I know my 4 rays of light don't all cross at the same point, but please notice that 3 of them appear to cross over here. So I'm going to take that to be the location of the image. If I was doing this on a sheet of paper with rulers and protractors, they all should have crossed at the same point. Please don't be too worried though, because the properties are what's important here. So our image will be roughly over here. And here are the properties I'd like you to take note of. First of all, when an object is placed between C and F, the image will always be larger. And that should be clear from my picture that the height of the image is larger than the height of the object. The second property is that it's also inverted. Notice now that the image is past C. And when we say past C, we mean to the left of C. And finally, this is also a real image. So those are the properties of images formed whenever the object is between C and F. And last but not least, case 4, what happens if you place the object on the focal point? This is actually the most interesting case of all. Something very strange happens. I'd actually like to encourage you to pause the video at this point, try it on your own. When you're ready, click play to resume. And here we go. Let's see what you got. I'm going to start drawing the 4 rays of light. Remember, the first one is parallel to the principal axis. This one reflects and passes through the focal point. The second ray of light that we usually draw is one that passes through the focal point and then comes out parallel to the principal axis. But we can't draw this one because our image is already on the focal point. So we'll skip it and we'll go to the next one that passes through C. Remember, this one comes back in the same direction it came in at. And the next one we'll draw goes through the vertex, which I'll label here. And it follows the law of reflection and reflects at the same angle it came in at. You did not make a mistake. Notice that the rays of light don't cross. So in this case, something very interesting happens. Because the rays of light don't cross anywhere, no image is formed. And the reason for this is all of the reflected rays of light are parallel and never meet. So do you remember in math, grade 10 math, when you were doing the linear systems unit, you were looking at how two lines could intersect and you use substitution and elimination to solve the system? You may remember when two linear lines were parallel, you got no solutions. This is very similar. When all of the reflected rays are parallel, they don't meet, and in a sense, we get no solution. But in our case, it's no image. So there's no way to describe the image because none is formed. Okay, and finally, everyone, we'll do case number 5. What happens when the object is between F and the mirror? The first ray of light that I'll draw is the one that is parallel to the principal axis. Recall, this one reflects and passes through the focal point. Okay, it's okay if it passes through the object, that's fine. The second ray of light that I'll draw is the one that passes through the focal point. So for this one, we actually have to go backwards. Imagine that a ray of light is traveling in this direction. So this one is coming in from the bottom left. It passes through the focal point, hits the top of the tree, hits the mirror like so. This one will reflect and come out parallel to the principal axis. All right, that was 2. The third one that I'll draw is the one that passes through C. Remember, this one just travels in a straight line, so we can sketch it like this. Okay, so that's the ray of light that passes through C, hits the mirror, and comes back in the same direction. And finally, there's also a ray of light that passes through the vertex. Let's draw that. This one follows the law of reflection and reflects at the same angle it came in at, something like this. All of the rays of light don't appear to cross anywhere. And that's because case 5 produces something a little more interesting. This is actually the only case where you produce a virtual image using a concave mirror. Recall when we learned about plane mirrors, virtual images formed on the other side of the mirror. So what happens here is you have to trace the rays backwards to the other side of the mirror and look at where they cross. So for the first ray of light that came in parallel to the mirror, it reflected and passed through the focal point. You just have to extend the reflected ray behind like so. The second ray of light that I drew was the one that passed through the focal point, reflected off the mirror, and came out parallel to the principal axis. Just draw a dotted line for the reflected ray of light behind like so. And you can already see that they're starting to converge somewhere on the right-hand side, but let's continue. The third ray of light that I drew was the one that passed through C. So we'll just continue drawing the reflected ray behind the mirror. Okay, and again, you'll start to see it's converging at that point. And finally, the last one I drew was the one that passed through the vertex V, which I think I forgot to label, but that's okay, I'll just do it now. Okay, and we just continue and we just draw a dotted line for the reflected ray of light behind the mirror. So it'll do something like this. Okay, so unfortunately that one doesn't quite line up with the other ones, but again, I'm not using a ruler and protractor, so please forgive me. But what I'm happy with is that the rays of light appear to converge somewhere over here. So our image will be approximately at this location. And that's what happens in case number 5. So when you place your object between F and the mirror, you are definitely going to form a virtual image. And that's the only case where you form virtual images with a concave mirror. This image has the following properties. Number 1, it's larger. Secondly, it's upright. As for the location, it's behind the mirror. And like I said, it's virtual. So just to summarize, cases 1, 2, and 3 formed real images. Case 4, we formed no image at all. In case 5, we formed a virtual image. And that's going to wrap up this lesson. Please try the following questions for practice. This was definitely a more complicated lesson, but please be patient with yourself. You will get it. You just might have to re-watch the video a couple of times. Hang in there. If you have any questions, don't hesitate to reach out. Thanks for watching, and we'll see you in the next video.